The forgotten giant of Mount Owen. In the remote wilderness of New Zealand's South Island, where limestone cliffs rise sharply against alpine skies and the winds of centuries whistle through rugged valleys, lies a story etched in bone and stone. On the jagged ridges of Mount Owen, within the vast expanse of Kahurangi National Park, an extraordinary discovery opened a window into a lost world. The preserved skeleton of a giant bird, the Mount Owen moa. The moa were flightless giants, symbols of New Zealand's unique ecosystem, towering up to 3 meters tall. For centuries, they thrived in the forests, grasslands, and highlands of Aotearoa. Yet by the late 15th century, they were believed to have disappeared forever, hunted into extinction by the first Maori settlers and their reshaping of the land through fire and cultivation. The Mount Owen find challenged this narrative. In 1986, caver Michael Dawson and a team of biologists descended into a hidden cavern system, accessible only through a vertical shaft cloaked by rockfall and vegetation. Inside, they stumbled upon what seemed impossible: a nearly intact skeleton of Dinornis robustus, a South Island giant moa. Its bones lay articulated, vertebrae aligned, limbs still in place, as if the creature had only recently fallen. Feather impressions clung to the femur, suggesting the thick plumage that once covered its body. The preservation was so remarkable that the skeleton appeared almost poised to rise again, striding across the ancient beech forests it once called home. Radiocarbon dating revealed that this bird had died around 3,200 years ago, centuries before Polynesian voyagers set foot on New Zealand shores. Unlike moa bones typically found in middens, refuse heaps left behind by human hunters, this skeleton lay undisturbed in a cavern far from any settlement. It was a portrait of moa life before human contact, a glimpse into a world untouched by people. The scientific investigations that followed painted a vivid picture. Collagen analysis revealed dietary signatures of tussock grasses and alpine shrubs, proving this bird had adapted to high altitude, living rather than lowland forests. CT scans of its femur showed growth plates, not yet fused, marrow still active. This was a juvenile, a bird in late adolescence, still growing when it met its end. Stable isotope studies suggested that some moa herds may have migrated seasonally, climbing into alpine zones during summer months to feed on nutrient-rich plants before retreating to the valleys below. But questions lingered. Why had this young moa ventured so high into Mount Owen's harsh terrain? The cavern where it lay was accessible only by a narrow shaft. Did the bird fall through a concealed sinkhole, mistaking the ground above for solid footing? Or had it fled into the cave for shelter, perhaps from predators such as Haast's eagle, only to be trapped when mud gave way beneath its weight? Geological studies revealed that the chamber had been shaped by periodic flash floods, torrents of water and silt sweeping in and sealing organic remains within hours. Thin clay bands on nearby stalagmites confirmed repeated flooding episodes. It is possible the moa was caught in a sudden deluge, its body entombed before scavengers could reach it. Adding to the mystery was a single footprint found near the skeleton's neck, pressed into the clay as if marking the bird's final moments. The print, frozen in time, deepened the sense of tragedy and awe surrounding the discovery. The Mount Owen moa also reignited debates beyond paleontology. Could this high-altitude specimen represent a unique mountain-dwelling population, long vanished without leaving further trace? Or was this bird simply an outlier, a wanderer whose fate was sealed in a cave that became its tomb? Some fringe theorists even suggested stranger possibilities, that its preserved posture hinted at locomotive abilities beyond walking, perhaps short bursts of gliding from cliffs, though no evidence supports such claims. Others speculated about early human involvement, theorizing that the cave might have been used ritually, with moa bones revered as sacred relics. Yet no artifacts or signs of human activity were ever found within the cavern. Attempts to extract ancient DNA initially yielded only degraded fragments, confirming species identity but revealing little else. Today, advances in paleogenomics raise the possibility of recovering entire nuclear genomes, which could unlock secrets of the Moa's immune system, growth, and evolutionary relationships. But with each test comes a dilemma. Every sample taken risks damaging an irreplaceable specimen, forcing researchers to balance the thirst for knowledge against the responsibility of preservation. The Mount Owen Moa's story reaches beyond science. It forces us to reimagine New Zealand before human settlement, not just as a land where colossal birds roamed forests, but as a complex ecosystem of creatures adapting to niches we have only begun to understand. It challenges the simple narrative of extinction and loss, showing resilience, adaptation, and mystery in a species long thought to be fully understood. As dawn breaks over Mount Owen today, its jagged crags shrouded in mist, the cave remains sealed, protected by conservation authorities. The skeleton rests in quiet darkness, its fragile bones safeguarded for future generations. But the legacy of that find lives on, in museum exhibits, in laboratories, in textbooks, and in the endless questions it inspires. What other secrets lie hidden in New Zealand's alpine caves? How many more skeletons, preserved in mud and stone, wait for discovery? Could we yet uncover evidence of alpine refuges where Moa survived far longer than we ever imagined? What other secrets lie hidden in New Zealand's alpine caves? How many more skeletons, preserved in mud and stone, wait for discovery? Could we yet uncover evidence of alpine refuges where Moa survived far longer than we ever imagined? The Mount Owen Moa reminds us that history is not a closed book, but a landscape of stories still buried beneath the earth. Its bones, silent yet eloquent, call us to listen more carefully to the rhythms of land, stone, and time. They whisper that even in extinction, life leaves echoes, and sometimes, in the most unexpected places, those echoes resurface to tell their tale. Enigma of the Atacama Skeleton. High-resolution CT imaging of the femur revealed internal features indicating the remains belonged to an individual in late adolescence. The bones not yet fully fused and marrow tissue still pointing to active growth. Was this youthful figure wandering alone, compelled upward by instinct or environmental change? Much like the preserved yet puzzling remains of the Mount Owen Moa resting deep in alpine caves, our focus now shifts to a wholly different mystery. Instead of frozen mountains, this story begins beneath the blazing skies of northern Chile's Atacama Desert, where a diminutive skeleton was discovered, not encased in ice, but lying beneath sun-scorched plains. This is the tale of Ata, the so-called Atacama humanoid, whose remarkably small size and peculiar physiology have ignited debates from cutting-edge genetic laboratories to speculative online communities worldwide. High-resolution CT imaging of the femur revealed internal features indicating the remains belonged to an individual in late adolescence. The bones not yet fully fused and marrow tissue still pointing to active growth. Was this youthful figure wandering alone, compelled upward by instinct or environmental change? Much like the preserved yet puzzling remains of the Mount Owen Moa resting deep in alpine caves, our focus now shifts to a wholly different mystery. Instead of frozen mountains, this story begins beneath the blazing skies of northern Chile's Atacama Desert, where a diminutive skeleton was discovered, not encased in ice, but lying beneath sun-scorched plains. This is the tale of Ata, the so-called Atacama humanoid, whose remarkably small size and peculiar physiology have ignited debates from cutting-edge genetic laboratories to speculative online communities worldwide. Picture yourself standing in the blistering emptiness of a remote salt flat, the wind carrying glittering crystalline dust beneath an unforgiving sun. At the base of a gently sloping ridge, among crumbling adobe ruins and remnants of abandoned mining outposts, you look down into a shallow hollow where the bones of a tiny being have been exposed by centuries of erosion. Barely the length of a human hand, only 15 centimeters from head to toe, the skeleton's elongated skull appears both eerily human and strangely alien. Around the eyes and mouth, delicate orbital openings and a narrow jawline echo the features of an infant, yet their proportions hint at forces far beyond typical human development. The bones were first discovered in 2003 when a local photographer stumbled upon them near the abandoned settlement of La Noria and captured images that quickly spread online. By 2009, the remains had entered the possession of private collectors and documentary producers, catapulting Ada into international intrigue. What began as an unusual find in the desert sands soon evolved into a deeper, far more human narrative as scientists traced the mystery from discovery to genetic decoding. Serious research began when Dr. Gary Nolan and his team at Stanford University received authorization to conduct extensive studies. Detailed CT scans revealed numerous skeletal abnormalities. Ada possessed only 10 ribs instead of the usual 12, a flattened thoracic cavity, malformed vertebrae showing signs of severe scoliosis, and a skull far thicker than normal. These were indicators of developmental disorders rather than evidence of a previously unknown species. Further analysis of bone density, epiphyseal fusion, and tooth development revealed that the individual had likely lived between 6 and 8 years. The most definitive findings came from DNA sequencing. Genetic material extracted from bone and tooth samples confirmed Ada as a member of a human species, with maternal ancestry tracing back to indigenous Andean populations. Mutations were found in several genes related to bone growth, including FGFR3, which is associated with achondroplasia and other dwarfism conditions, as well as rare variations in genes regulating growth plates and collagen production. These results portrayed a child with severe congenital disorders whose body had adapted in extraordinary yet tragic ways. Yet profound questions remained. How did a child with such extreme skeletal deformities end up buried in an unmarked grave in the desert? Why were the remains left undisturbed for possibly a century before being uncovered? Archaeologists note that in such environments, small bones are typically scattered by scavengers or erosion. The fact that Ada's skeleton was still partially articulated, ribs clustered around the spine, limbs in natural alignment, suggests a rapid burial, perhaps in a shallow grave later concealed by shifting dunes. Could local communities have deliberately buried the child, offering respect despite the unusual circumstances? Historical records offer only fragments of context. La Noria thrived as a nitrate mining town during the late 19th and early 20th centuries, drawing migrant workers from the Altiplano and beyond. These temporary settlements often built makeshift cemeteries for laborers who died from accidents, disease, or exhaustion. It is plausible that Ada was born in such a transient community, where its physical differences were viewed either as a curse or a sacred sign. Perhaps a grieving family buried their child with small offerings, now lost to time, before leaving the region, the remains eventually surfacing as a message from the past. Unsurprisingly, extraordinary discoveries breed extraordinary theories. Some fringe researchers propose that Ada's elongated skull and tiny ribs were evidence of an ancient hybrid species, a cross between humans and an unknown hominid. Others speculated about secret government experiments, suggesting the skeleton was the result of genetic engineering for pediatric spaceflight. But these ideas collapse under the weight of scientific data. The DNA is entirely human, and the high frequency of congenital bone mutations offers a much simpler explanation. The story of Ada also resonates with Andean spiritual traditions. In Aymara and Quechua cosmologies, children born with deformities were sometimes believed to be wary, spirit beings who bridged the worlds of earth and the high plains, Puna. Such children might receive special rites, their graves marked with stones or coca leaves. Could Ada's burial site once have held ceremonial importance, a sacred threshold where families sent a loved one into the realm of spirits? The bones may have served as a physical link between the living and the supernatural. Chemical analyses of sediments adhering to the skeleton detected organic compounds, resins, and plant alkaloids consistent with aromatic shrouds or herbal treatments. possible evidence of intentional burial practices. While these substances could have originated from natural desert processes, their concentrated presence on bone surfaces suggests ritual preparation. If so, Ada's passing may have been marked by a ceremony now lost to history, its participants erased by time and wind. The condition of the remains adds another layer of intrigue. The bones show little sun bleaching and minimal microbial decay, indicating that they were periodically covered by sand rather than exposed continuously. Geological evidence suggests shifting dunes repeatedly buried and revealed the grave throughout the 20th century. Yet the skull's facial features remain remarkably intact, as though shielded from direct sunlight, possibly by cloth wrappings or a small wooden container that has since decayed.